All right. Hey, kids. I wanted to talk to you about this new problem we're doing today, which is about graphing. So, we've done some graphing work and we've done some table work, and this is kind of bringing those two things together. And I think one of the important things on this one is that you're able to use the graph in a way that you can predict what's happening in the middle. So, this story is about Miss Sims, or Ms. Sims, a fifth grade teacher, noticed that the classroom roof had a leak. Not a good thing, right? You don't want a leak in your classroom, that'd be bad. And today at 9 a.m., she put a measuring bucket under the drip, which is a sensible thing to do. If I have a drip coming from my ceiling in my classroom, what am I going to do? I'm going to get a bucket. I'm going to put a bucket under it. I'm going to let it fill up, and it's hopefully they can fix it. Because obviously we're not climbing up on the roof to fix it ourselves. So you catch the water so it doesn't go all over. So this seems like common sense, right? And then the water from the leak dripped steadily. This is important. This notion that when we measure things in math, often at this level of math, we're talking about things happening at a consistent rate or a consistent pace. And that matters in terms of graphing, it matters in terms of growth. If something's happening all willy nilly all over the place, like there's no real sense of it. But if something's happening where we can say, well, this is what it's growing by, or this is how much is leaking every minute or every hour, whatever, right? That actually makes sense. And if you think about it, a slow drip coming from the ceiling would take hours to kind of like make to fill up a bucket. So in this case, if at 9 a.m. in the morning, like the beginning of the school day, the teacher noticed that there was like a drip, right? She put a bucket under it. By 11 a.m., 2 hours later, there were 3 liters of water in the bucket. That's a lot, by the way. 3 liters. Think about a 2 liter bottle of Coke or of soda, and then another 3 liters would be, another half again as much. That's a lot. So 3 liters of water. That's more than a drip. That's quite a bit. But what we're going to say is, because it's a steady pace, we're going to say what's going to keep happening. So on this table, you see at 9 a.m., there was 0 liters of water. At 10 a.m., or at 11 a.m., there was 3 liters of water. What we don't know is what happened at 10. So one thing I'm going to ask you to think about is, how would I figure out what happened at 10 a.m.? What's halfway between? What would happen if I would have measured it at 10 a.m., right? Now, the next time on our table is 1 p.m., 2 hours later. So remember, 9 a.m. plus 2 hours is 11 a.m. Plus 2 hours is not 13 a.m., it's 1 p.m., right? The time moves over into the p.m., you get 1 p.m. And then at 3 p.m., you have another 2 hours have passed. So every 2 hours, it seems like we're gaining 3 liters of water. So I want you to fill out this table. Now, that's pretty straightforward, pretty simple. Now, the next thing says on the opposite page, and all that means is the step below, we want you to graph it. And what I did, and this is what I really wanted to show you today, is I'm going to double click on this and hope that it works in our video. When I double click on this, and it does work, this is exciting. Okay, when it does work, I'm going to shrink this a little bit. There we go. We can now see that this is a drawing, right, of what's happening. And we said on one, and I know you see this. I'm going to try to turn this off. Hold on. There we go. On the bottom, we're measuring time: 9 a.m., 10 a.m., 11 a.m., 12 a.m., 1 p.m., or 12 p.m., 1 p.m., 2 p.m., 3 p.m., 4 p.m. This is time. On the y-axis, we're measuring volume, how much is coming out, or how much liquid is filling up. So it starts at 0, goes up by 2. Now, does that mean 3 and 5 and 7 don't exist? No, it means they're halfway in between, and that's really important. We need to know where 3 is. It's halfway in between. So what I'm going to do in this drawing, see, I got all these pieces over here. I'm going to say, well, I know, and I grab this. See how I just grabbed that? I just grab it. I grab this dot, and I say, I know at 9 a.m., there's no water. It's just the drip just started at 9. So I put that dot right there. I click off of it. I look at it. I say, okay, I've got my first drop at 9 a.m. It's on 0. I know you can't really see 0, but it's right there. Okay, now, what happens at 11? Well, at 11, I'm going to grab another one of these, and I'm going to say it's at 3. Now, if I put it here, I'm too low, right? I'm at 2. If I put it here, I'm at 4, too much. So what do I want? I want it right in the middle. I move it down to right in the middle. I keep it on the 11, and I put it right in the middle. I click off. Now look where it is. It looks like it's just in the middle between 2 and 4, which means at 11, which is on our chart, it's at 3. And by the way, the other way I can move it is I can hold down the shift button and the arrow keys, and I can move stuff around that way. So at 11 o'clock, there are 3 liters in the bucket. Now, as we move forward, you're going to think, okay, well, if another 3 liters of water will fill up after another 2 hours, we're now at 3 liters. After 2 more hours, won't I be at 6? Like, wouldn't I be able to take this one and put it right here over on the 6 at 1 p.m.? Now, what you start to notice is that this shape, or that what's happening here is a straight line. So this line right here, which I'm going to boost up, I'm going to make this thing, let's make this blue because it's water, and let's make it thicker. Yeah, that's it. Okay, I'm going to take this line, and I'm going to extend it from the middle of this one, right, all the way to the middle of that one. I'm going to try to make it go straight through. You see that? I'm trying to line it up. Now, that line represents the pace of what this is doing. And if I was going to continue it, I would be like, well, it's going to keep going straight from there. You notice I can move this around. So, like, I can make this line go like this, but that doesn't make any sense. I can make it go like this, or I can make it line up. And you guys can do this. And when I line it up, it tells me that this is the pace at which the water is dripping. Which means, what if I want to know how much water this is going to be at 12? Well, I'd look at 12 and I'd follow the line up, and right here I'd say, well, it's a little more than 4, but it's not quite halfway. So I'd say it's like maybe 4, above 4. At 12 o'clock, there would be a little more than 4 liters in that bucket. But by 1 o'clock, there's 6, right? So I'd say maybe here it's like 4.5. So I can find in between points, if I'm careful, if I look closely at my graph. And that's what you guys are doing. You're building this graph. That's your idea. Build the graph. I want you to set it up. I want you to draw the points. You're going to put the points for 3 o'clock and for 6 o'clock. Now, on our table, it says 7 o'clock, but we don't have to do that because it's not even on our graph. So you just have to place all of the points and draw that line, or make that line happen. Okay, so then I'm going to save and close when you're done. And now you see your graph is done, right? It's finished. I scroll down a little more and I look and I say, all right, at about what time were there 8 liters in the bucket? So I go back here, I look at my graph and I say, when did the line cross 8 liters? And I say, what time was it when it hit 8 o'clock? So I go to 8 liters, I bring it across, and then I come straight down. And if I come straight down right here, I start to notice where it falls on the time. About what time would that be, right? So that's kind of how I find a point on a line, even if it's not on my table. Pretty cool, right? And the last question, the bucket holds 20 liters of water. If the school janitor comes to deal with the classroom at 6 p.m., which is the end of our graph, will the bucket have overflowed? How do you know? So this is all about like reading the graph, understanding what's happening. So we have a table and we have a graph. All right, you guys are going to be doing this, so this is your job. And you don't have to do it in your notebook. It's all stuff you can do right here, which is fantastic, right? No notebook work today, or no notebook for this one, just all in the document. Okay? All right, so once again, it's all about this graph and about that table and that graph. Totally fun. Hopefully, the classroom doesn't flood all the way. All right, here we go. Bye, everybody.